Welcome to today's webinar, Deep Dive on Elastic File System. Our presenters today are Ed Nain, Daryl Osborne, and David Green. Ed is the product head for Amazon Elastic File System. Daryl is a storage solutions architect, and David is an enterprise solutions architect with AWS. Today with us, we also have Prash. Prash, along with our other presenters, will be moderating and engaging with you in the Q&A pod, answering your questions throughout the presentation. Ed, Daryl, and David, welcome. The floor is now yours.
Great, thanks. Welcome, everyone, and thanks for joining us today. This is Ed Nain. As Joe mentioned, I lead the product team for EFS, and I'm joined by Daryl and David, who are both solutions architects at AWS. We are really excited to be doing this webinar today. We had launched EFS as a generally available service about 8 months ago, and customers are using it for a wide swath of applications and workloads, which we're really happy to see. This webinar is a 200-level overview on EFS, and it's aimed to help you understand how EFS can solve your storage needs and how to get the most out of EFS. We have lots of content planned for the webinar, and we'll start off by talking about why and when to use Amazon EFS. We'll go through some technical and security concepts that are important for everyone to understand. We'll talk about how to leverage EFS's performance model and get into some details around how to optimize your applications and your workloads to leverage the performance that EFS provides. We're then going to do 2 different demos. One is focused on a real-world application running on top of EFS, so WordPress, and the other is about how to move data as quickly as possible onto EFS. We'll then spend some time looking at EFS's economics and total cost of ownership, and we'll leave about 10 minutes at the end for answering your questions. So without further ado, let's get started. And let me start by talking about AWS's overall storage portfolio. We have 3 core classes of storage. So the first is block storage, which is represented on this page by Amazon EBS and Amazon EC2 Instance Storage. And block storage presents your data to your instance as a disk volume. And it provides the lowest latency access to your data from single EC2 instances. And EBS, for example, is really popular for things like boot volumes and databases that have very low latency requirements. To the right, you see object storage. And an object is a piece of data, like a document or an image or a video, that's stored with some metadata in a flat structure. And object storage provides that data to applications via APIs over the internet. So with our S3 service, it's super simple to build, for example, a web application that delivers content to users by making API calls over the internet to get the data. Glacier is another form of object storage we have that's focused on archival storage. And as of 8 months ago, with the announcement of general availability for EFS, we now have file storage. And with file storage, with EFS, data is presented via a file system interface and with file system semantics to your EC2 instances. When attached to an instance, EFS acts just like a local file system would. And EFS provides shared access to data to multiple EC2 instances, all with low latencies. On the bottom half of the slide, you see our cloud data migration offerings. And these services help customers migrate data into and out of the AWS cloud in offline, online, or streaming models. So a bit more on exactly what EFS is. So first, EFS provides standard file system interface and standard file system semantics. So you get what you would expect from a file system. It works with operating system APIs for interacting with files. It allows you to take out locks. It provides strong read after write consistency, etc. So really everything that you would expect from a local file system, you get with EFS. Secondly, it provides shared storage. You can use EFS with a single instance, with multiple instances, 2, 10, hundreds, even thousands of instances. And all of those instances will have access to the same set of data that's in EFS, and we'll see the data in a strongly consistent manner, so strong read after write consistency across those instances. 3 and 4, EFS is designed to be highly available and highly durable. So every aspect of the service is designed for high availability, and a big part of that which is also important for durability, is that data is stored across multiple availability zones. So you can think of EFS as being designed like S3 in terms of availability and in terms of durability. EFS also provides consistent low latencies, which is really important for a broad spectrum of applications and workloads, and it's designed to be really scalable. So storage can scale to petabyte scale, and throughput can scale to multiple gigabytes per second. It also provides that capacity elastically. So when you create a file system, you don't actually provision a storage amount. You just create this file system resource, and you add data to it, and as you add data, the file system automatically grows, and you're billed only for the bytes that you're storing. And it's fully managed. So you don't have to manage disks, you don't have to manage a software layer that is enabling shared access. You don't have to manage growing the file system. It's completely managed for you. And with EFS, we focused on changing the game. There were three core parts of our design. We designed EFS to be really simple. We designed it to be elastic. We designed it to be scalable. And all of that is on top of high availability and high durability. And let me talk about each of these quickly in turn. So first of all, it's simple. It's a fully managed service, which makes it simple to administer file systems at scale. So there's no file layer or hardware to manage. There's no volumes, LUNs, RAID groups, provisioning management, none of that stuff. And you can create a scalable file system in seconds. And that might be hard for people who are on this call who've managed shared file storage before to believe, but it's true. It's very simple to create a file system. It also provides seamless integration with existing tools and applications. It supports NFS version 4.1, which is a widespread and open protocol. As I've mentioned, it supports standard file system access semantics, and it works with standard operating system APIs for interacting with files. And it provides simple per gigabyte per month pricing, which makes forecasting pretty easy. It's also elastic, so file systems grow and shrink automatically as you add and remove data. You don't provision storage capacity or performance, and again, you're billed only for the storage space you use. There's no minimum fee, so completely elastic. And it's scalable. It can grow to petabytes of capacity. The throughput that you're provided can grow to gigabytes, multiple gigabytes per second, and it scales automatically as the file systems grow. So the amount of data that you have in the file system, as that increases, the amount of throughput that you can use to access the data also increases linearly. It provides consistent low latencies regardless of the file system size, and it allows support for up to thousands of concurrent connections. And again, it's designed to be highly durable, highly available. Every object is redundantly stored across multiple AZs in a region. Every component of the service is designed from the ground up to be highly available. It's designed to sustain AZ offline conditions, so if a particular availability zone is offline, you're still able to access your full set of data from the other AZs. And all of this amounts to a model that's superior to traditional NAS availability models and really makes EFS appropriate for production, Tier 0, Tier 1 applications. So, what regions can you use EFS in today? 4 regions right now: US West, Oregon, US East, Northern Virginia, US East, Ohio, and EU Ireland. And there's many, many more coming soon. Our goal is to have it be globally available as soon as possible across as many regions as possible. And a question that I often get is, should I use EBS or EFS, and how do I think about that? Well, here's a simple framework to use for thinking about that. So if you have an application, and either one that's running on EC2 or on-prem, and I'll talk about the on-prem piece in a little bit, and you have a use case that requires a file system, and that file system either requires multi-attach, so access from more than one server, more than one EC2 instance, or multiple gigabytes per second of throughput, or availability or durability that is across availability zones, or requires automatic scaling, so growing or shrinking of your storage, then you should really think about EFS and give it a try. And customers are using EFS today for a broad spectrum of workloads and applications. Web serving and content management are very popular use cases for EFS. Analytics and big data type workloads are often very file focused, and so those are core use cases that EFS serves. Media and entertainment workflows similarly are generally file based and require low latencies and very high levels of throughput and access from tens or hundreds of instances. Database backups is another popular one. It's being used very heavily for container storage, home directories, and just general workflow management where you want to have shared state across more than one instance. So really interesting spectrum of workloads. Okay, so let's get into some of the technical concepts. And let me start off with a definition. File system, which is the basic resource that you create with EFS. It's the primary resource, and that's where you store your files and your directories. And you can create up to 125 file systems per account. And then we have this notion of what's called a mount target. So to access your file system from within a VPC, you create mount targets in the VPC. And a mount target you can think of as essentially an endpoint that provides a DNS name and an IP address that you use in your mount command when mounting your file system on an EC2 instance. And these mount targets are designed to be highly available. And so what does accessing a file system look like? Well, you use the standard mount command on a Linux instance, and with that command the file system will appear like a local set of directories and files. We show on this slide what that standard mount command looks like with EFS. You provide the mount type, which is an NFS4 mount, the NFS version number, which is 4.1, and you provide that file system DNS name that I was mentioning the mount target provides, or you could use the IP address if you preferred, and then the local directory that will be the target directory for the mount point. So that's all you do to mount the file system on an instance. So how does it all fit together as a summary? A file system belongs to a region, and within that region you have multiple availability zones, and the file system spans the availability zone, so it's accessible across availability zones. You have a VPC, this is your VPC, and that also spans availability zones. And within each availability zone, within your VPC, you will create a mount target, and that mount target is what's used by your instances within each AZ and within that VPC to access your file system. And we provide several security mechanisms to protect access to your file system, to your data, and to the management tools around your file system. So first, at the network level, you can control network traffic to and from file systems by using VPC security groups and VPC network ACLs. And essentially, you apply those to your mount targets. So you specify what traffic is allowed to reach your mount targets, and in turn, then which traffic is allowed to reach your file system. You control file and directory as access by using standard POSIX permissions at the data access level. And then at the administrative level, you control administrative access to your file systems using IAM. So EFS provides a simple API that you use to manage your file system. And there's not a whole lot in that API because there's not a whole lot that you need to do to manage your file system. So the API allows you to create, delete your file systems, to create and delete the mount targets, create and delete tags, and view some details on the file systems that you have in an account. And you can use IAM to control who's able to call which functions on which file system. So it's an action level and resource level permissions via IAM. And at reInvent, we announced the ability, a new feature, for you to access your EFS file system from on-prem servers using AWS Direct Connect. And for those who aren't familiar with Direct Connect establishes a private network connection between your on-prem environment and AWS, which bypasses the internet entirely. And one of the benefits of a Direct Connect connection is improved latencies and throughput compared to connections that route over the internet. So with this feature for EFS, You can mount your file system from an on-prem server or multiple on-prem servers with the same NFS for one mount command that you'd use from EC2 instances. And generally, when we think about hybrid access to the cloud and what something like Direct Connect access provides, there's 4 different scenarios. So the first is migration, and what we mean by migration is you're moving your applications and your data over to the cloud. The second is bursting, so your data sits permanently on-prem, but once in a while you want to do some processing on the cloud, so you would move your data onto the cloud, bring up an EC2 cluster, process the data, and then move the data back to on-prem. There's tiering, which means that your data is, some of your data is stored on-prem, some is stored on the cloud, and there's some efficient tiering that's happening between the two based on access patterns. And then there's backup and disaster recovery, where your primary data is on-prem, but you have a secondary copy on the cloud for backup and for disaster recovery. So the Direct Connect feature enables 3 of those 4, so the migration of data and bursting of workloads, backup, and DR. It's not something that we recommend for tiering, and again, tiering, you would have your application on-prem, your data partially on the cloud. We don't recommend that because of the latencies that some Direct Connect connections have. Those latencies vary depending on the Direct Connect connection itself, but in some cases those can be tens of milliseconds, and for a lot of applications those latencies are unacceptable. So really 3 of those 4 hybrid scenarios are supported by the ability to mount over Direct Connect. So let's talk in more depth about EFS's performance model. And let me start by saying that EFS is designed to serve the vast majority of file workloads. That covers a wide spectrum of performance needs. So from big data applications that are massively parallelized and require the highest possible throughput to single-threaded, latency-sensitive workloads. So examples across that spectrum are things like genomics analysis, big data analytics, scale-out workloads, web serving and content management, and then some metadata-intensive jobs that oftentimes are serialized and small I/O, and so latencies really matter in those cases. And to support this broad spectrum of workloads, EFS offers 2 different performance modes. Most customers are best served by what we call the general purpose performance mode, and that's in fact the default mode for EFS. And that's appropriate for most applications, including web serving, content management, software build systems, home directories, and just general purpose file workloads. And what general purpose mode is it's a mode that's optimized for the lowest possible latencies for your file operations. So relative to our other performance mode, which we call max I/O mode, you get the lowest possible per operation latency when you're in general purpose mode. The trade-off is that you're limited to 7,000 operations per second when you're in general purpose mode. With max I/O mode, there isn't such a limit. So max I/O mode really is for large-scale, data-heavy applications, large scale-out applications where they need virtually unlimited ability to scale out in terms of throughput and IOPS. And the trade-off with max I/O mode is you do get slightly higher latencies for each of your file operations. So what we generally recommend is, if you're unsure of which mode to be in, you should start in general purpose mode, try your application in general purpose mode, and see what the performance looks like. If it's not appropriate, you can try max I/O mode. And a good way to understand what the performance looks like is we provide a CloudWatch metric, which we call the percent I/O limit, and that shows you how close you're getting to that 7,000 IOPS limit that's part of general purpose mode. So if you start off in general purpose mode, you test your application, and you take a look at the CloudWatch metric, and it doesn't show you getting near 100%, then general purpose mode should work for you. And to understand EFS's performance model, it's helpful to provide some color on EFS's architecture. And fundamentally, EFS has a distributed data storage design. And what that means is that file systems are distributed across an unconstrained number of servers. And what that does is it avoids the bottlenecks and the constraints of traditional file servers, where you'll have one or a small number of servers serving data. And that enables high levels of aggregate IOPS and throughput. It really enables the scale out that we've been talking about. And at the same time, data is also distributed across availability zones, which we've been talking about as important for durability and for availability. And so this distributed architecture has some performance implications. And one way to think about that is to compare EFS to EBS. Specifically, this table looks at EBS provisioned IOPS to understand some of the performance and other characteristics of EFS relative to our block offering. So first, from a per operation latency perspective, the distributed architecture that I was talking about results in a small latency overhead for each file operation. And that's really because when you're conducting a file operation, the data gets spread across multiple servers and spread across multiple availability zones. And so there's a latency that's associated with that. So EFS is designed for low and consistent latencies, but if you're looking for the lowest possible latencies, then EBS PIOPS provides that. The ability to scale out, though, is a key characteristic of that distributed design. And so EFS allows multiple gigabytes per second of throughput. And when you're looking at EBS, it's around a single gigabyte per second. Then in terms of data availability and durability, again, EFS data is stored redundantly across multiple AZs, with EBS is stored redundantly in a single AZ. In terms of access, EFS allows access from up to thousands of EC2 instances from multiple AZs concurrently, and EBS is designed for a single instance to access your data in a single AZ. So what this all boils down to in terms of use cases is EFS is designed for things like big data and analytics, media processing workflows, content management, web serving. So really use cases where you need some scale-up performance, or you need the multi-AZ availability and durability, or you need high levels of aggregate throughput. And EBS is great for things like boot volumes, transactional NoSQL databases, data warehousing. So really workloads where latencies are critically important, and the applications need access to the lowest possible latencies that they can get. Now keep in mind that due to this per operation latency, overall throughput generally increases as the average I/O size increases, since the overhead of these operations is amortized over a large amount of data. And by I/O size, I mean the amount of data that you're reading and writing in a single operation. And so this graph illustrates that as the I/O size on EFS for an EFS operation increases, the amount of throughput they're able to drive also increases. And again, that's because that overhead associated with how we're replicating our data gets amortized over a larger chunk of data. So in reality, you're able to drive more throughput with a larger I/O size. And EFS is designed to process high volumes of concurrent operations on a file system. And what that means is that you can send multiple operations in parallel by using multiple threads or multiple threads across multiple instances. And on this graph, we illustrate that where we held I/O size constant, and we had 10 instances, and we increased the number of threads per instance. And you can see that the aggregate number of operations increases almost linearly as we increase the number of total threads. And we'll show in a little bit some real-world examples of leveraging this fact to copy data faster via multiple threads. And EFS provides a variety of CloudWatch metrics to help you understand how your file system is doing from a performance perspective. I won't go through the details of all of these, but just want to let you know that they're there, and we have them documented in our online documentation. And the mount options that you use matter a lot, so as well as the kernel version. So we highly recommend using a Linux kernel version 4.0 or newer. It makes a really big difference in a lot of cases in terms of performance. So we strongly encourage kernel version 4.0 or newer with EFS. And we strongly, again, encourage mounting via NFS 4.1. EFS also supports NFS 4.0, but there's significant performance enhancements with 4.1, and so that's what we highly recommend. At the bottom of the slide, you see the recommended mount options. Most of these are the default options in most kernels, but we're calling them out because these things do matter. And so you may want to verify that the default options for the kernel version that you're using are in fact these ones. And we have all of these documented online. But it's a call out because these things are really important from a performance perspective. Okay, so at this point, we're going to move to our first demo, and I'm going to turn it over to David.
All right, thanks, Ed. So basically what I want to be able to show is the ability to move data as quickly as possible to EFS. And I'm a enterprise solutions architect, and I manage accounts that are mainly media entertainment workloads where they're either moving a large number of small files or a small number of very large media files. So I'm going to walk through both aspects here. So basically, we see many customers adopting EFS because of the ability to have a file system that's mountable. So some workloads that don't support object yet may include something like transcoding or processing or media pipeline. So this is what it looks like here to move some files. So my goal here is to move data as quickly as possible to EFS. So starting with media assets, some of these files are several hundred gigabytes in size per file, and the data could be sourced either from S3 or EBS from local disk as well. And the use case of many small files, we have small files ranging from 64K to 256K, and again, data sources could either be coming from S3 or EBS. And like Ed mentioned, I want to talk about serial versus parallel. So basically, a serial file transfer means that it's queued up. So it's like a race like this, or you're at a supermarket waiting for the transaction in front of you to complete before your transaction can start. And that's not what we want to do, especially with the cloud. We want to take care and keep in mind for horizontally scalable solutions. So we want to run in parallel like this. So there's a few ways to do it. One I'm showing here today is new parallel. And basically, this is a job that executes commands in parallel. And you can execute to a high number of threads per host. And it can reduce the number of machines needed to complete the job faster. And this is what it looks like for the command that I ran. And again, there's a lot of this that we can send, or it's also online. This is one example of many ways to do it. But basically, this will check for the directory and then copy based on a specified number of threads to the new directory. For example, source will be EBS, destination is EFS. And I really want to be able to optimize the transfers. So in my testing, I wanted to see what made sense, like what instance size was the best way to to spin up, and also have it be as cost effective as possible. So to do that, I ran this benchmark on several instances to determine the optimal instance size across the wide fleet of instance types that we have. And my initial test size was 1,000 small files, and that was spread across all instance types like T2, nano, small, medium, large, and so on. And on each instance, I increased the thread count. I iterated from 1 thread up to 1,024 threads. And here are the tools that I used to test. I had Datadog that monitored instance performance and metrics. I used Sumo Logic for log collection and visualization, and SaltStack to orchestrate my commands across hundreds of instances while I was testing. And these tools are in a partner ecosystem, and it's just super easy to set up. So here's the results that I saw. Using 4 instances, copying large files to EFS, I got about 450 megabytes per second. And this is how the stack was visualized with Datadog. So now that we know what the baseline is, I want to add additional instances for higher concurrency. So in doing so, using 50 instances, I was able to achieve over 4.2 gigabytes per second writes to EFS. And here's my test result with small files. So again, using all the different families of EC2 instances, I kind of wanted to see what was the best family to use and most cost-effective one. So as we see, the performance basically plateaus around 200 threads of concurrency. So that's my number I stuck with for concurrency. And when I compared the graphs, the C3 large had the same performance as the others. So here's all the others here as well. So C3 large was really the sweet spot for performance and cost. So now that I know I want to use C3 large for this one, I want to increase the number of instances to up to 300 instances to run my throughput test, and also optimize for cost. So I use the EC2 spot market. So when launching my instances, I have 300 instances selected here, and the EC2 spot market here was 1.6 cents per instance hour. And again, this price is variable, but it's typically far less expensive than running on-demand cost. And in using 300 instances, I was able to move over 1.6 million files per minute to EFS. And I can actually show a quick dashboard here of what that looks like as well from real-time perspective. So this is Datadog that's running live right now. We have some tests running, and currently I'm moving 10.8 thousand files per second. And earlier today, running a different type of test, I was running 168,000 files per second with EFS with only 300 instances. And on the left side there, we see this is the number of instances that have been, or number of files that has been moved over since the job started. So we go back to real time here, and we see that number increasing. So basically, at the beginning of the talk here, we kicked off a transfer, and I'm already up to 42 million files that have been written to EFS since the beginning of this talk. Next slide. Great. So yeah, basically, in summary, it's easy to move large files quickly, but small files can take some carries and parallelization tools. And parallelize everything. So whether that's the number of threads that you're running per instance, or even instances. And test. The results that you see for my testing may be different from what you may see with your environment and your file type. So just test out things that that way you know what tools would work best for you in your environment. And I like they basically capture everything, so that way you know you can repeat things in the future. And for my testing I showed today, I paid less than $5 for all 300 machines run in this test. So thank you.
Great, thanks, David. Well, over the years, the internet has really changed the way we deliver and consume information. From enterprises to nonprofit organizations, from the local pizza joint down the street to artists and individuals who just want to share a simple message or story with others. The internet has really transformed the way that we consume information and who has access to that information. The audience is massive as well because we're all connected. Whether we're at home or at work, on a bus or a plane, we're always connected and consuming content on the internet. There's a lot of applications and web platforms out there today that really help us deliver this content, but there's one that has become very popular with big corporations all the way down to really the person next door sharing their favorite recipes. WordPress has really made it easy and comfortable and affordable to create and publish beautiful websites. It's pretty remarkable when an application or a platform has at least 27% of the market with tens of millions of websites. So how are people using WordPress today? Well, WordPress, we have WordPress hosting providers out there that will manage the WordPress environment for you. So all you have to do is really create and publish the content. Then there's others who really want to do it themselves. And that's what we're going to talk about today. In WordPress, we have a number of different components. So, we create, manage, and deliver content from a web server. And the content you create and share, along with the application and configuration files, information like that, can either be stored in unstructured data or structured data. So if we map that to AWS, the web server will be running, of course, on Amazon EC2. Now this could be a single EC2 instance, or it could be a fleet of EC2 instances. The unstructured data needs to be accessed by all of the instances. So the data is the same and shared across all the instances within the fleet. So it can really deliver that same content. So this unstructured data is going to reside in Amazon EFS. And on the structured data side, this data actually sits in a database. So again, it needs to be accessed from all the EC2 instances, so we recommend leveraging a managed database service like Amazon RDS. So now that we know what this architecture sort of looks like, let's go ahead and do a quick demo. Excellent. So here's a very quick and easy website or a WordPress site that I set up. Very basic, a sample site, but I'm getting bored with it, so I want to go ahead and change the theme. So if I go into the dashboard, we can quickly add a new theme. Here we'll click on Add, and we'll search for a theme that I like. And we'll quickly install that theme. Now, just after a couple of seconds, the theme is going to be downloaded and installed, ready to go, and then I'll activate it. Now, this environment here is actually a single EC2 instance sitting behind an elastic load balancer, but it is in an auto-scaling group, so I can scale this fleet of EC2 instances up or down. Now that it's active, let's go ahead and go back to our site to see what this looks like. And we see it has a little newer, just a little better feel to it, which is great, and that's really what I was looking for. Well, let's say that there's an event coming up that we need to scale our fleet automatically behind this WordPress site. So if we go into our management console in our auto-scaling group, we see that we have a desired capacity of 1. Let's go ahead and change that, and let's scale our fleet up to 5. We know we have a lot of people that are going to be hitting the site here soon. So while that is launching, we can take a look at the instances, and if we refresh this, we'll see a number of instances starting to be created and launched as a part of our auto-scaling group. While it's doing that, let's go ahead and go into the instance and actually SSH into this instance to take a look at how this instance is connected to EFS and make a couple of changes to it. So we'll go over to our terminal. We'll go ahead and SSH into this box. Now, when I log into an EC2 instance that has an EFS mounted to it, I'd love to take a look at our disk file system. And we take a look here, we see that our EFS file system is mounted here. And can anyone do a very quick calculation on how large this file system is, how it's showing? Pretty big, isn't it? So if we do a quick, just that's 8 exabytes it's showing to the file system, to the operating system. So that's amazing. So how do we, though, mount all the file system to these EC2 instances that spin up as a part of the auto-scaling group? Well, there's really two important components of that. If we go back to our management console, now we can take a look. There's two elements here that I want to sort of point out. The first is the IAM instance profile. So I have a role in IAM that is EFS read-only. What this does is it really allows an EC2 instance to execute an EFS, describe EFS file system API command so that I can query and get the file system IDs. Another very important part is this user data. So if we take a look at the user data, we'll pull it up here, and we'll quickly look at this. We'll save it so it's a little prettier. Now, this is what each EC2 instance is going to run as a part of the user data when it launches. So it's going to install a couple of packages. But down here, it's interesting. So here, we actually grab the instance ID using the metadata from the instance. We also grab the availability zone from the instance ID. And from the availability zone, we're able to determine what region we're actually in. So I can actually have this script launched on any of my EC2 instances in any region, and it's really not going to change. Then I execute an EFS describe file system command. It's a AWS CLI command. And what I'm doing, I'm actually looking for a file system and to get a file system ID where the file system has a key value or a name of WordPress EFS. So it's looking for that tag with the value, or with the key name and the value WordPress EFS. Once it finds that, it'll go ahead and store that file system ID. Later on, I'll go ahead and mount that file system ID, do a couple of other things for Apache, and go ahead and start the Apache server. So it's very easy then to automatically mount these EFS file systems to instances that run as a part of an auto-scaling group. If we hop back to terminal, we can take a look at a mount command. And we can see that, yeah, here's the file system that's mounted. We see the directory that it's mounted to, and we even see the IP address and any of the mount target, as well as any of the mount commands or options that were executed as a part of the mount command. So let's go ahead and take a look at the directory. And we see that Cloud Viking is the site that I'm running. So if we go into Cloud Viking, we can see that there's a number of PHP files. We have the WP content in here. In the WP content, we see that we have our plugins, our themes. All this information is stored here within EFS. So as a test, I want to, and as a part of my page, I want to go ahead and install, make a change to a PHP file that puts in the instance ID to the web page, so that I know what instance I'm actually running on. This isn't something you do in production, but for this test, I want to go ahead and do that. So I've got a script here that can easily copy a file that I have these changes already made in the header file of my WordPress site over to the current site. So now if we hop back to our site, we can take a look at what it looks like now. Now, this should actually have the instance ID right underneath. So great, we know that we're running on this instance ID. Well, let's say we want to make another change to it. So if we go back to our themes, let's go ahead and customize our theme, and we want to add an image. So let's go ahead and go into the site identity. Let's select a file, and let's grab a file, an image that we want to upload, that we want to share as a part of the header page for my site. We'll go ahead and upload this to WordPress. We'll go ahead and choose that file. And let's go ahead and make sure that that file is going to be displayed in the logo and the tagline. Let's go ahead and save and publish this information. And I like what it looks like. So I think that's going to be good. So now if we hop back to our WordPress site, what everyone sees, and we do a refresh, we're going to see that now that image, do a refresh, that image is going to be there. We'll have the instance ID, and as we scroll through this, we hit all the different EC2 instances in our auto-scaling group. We see that the instance ID will continue to change. So we're actually hopping from one instance to another behind our ELB, and it's sharing the same data that we uploaded So it makes managing a WordPress site and maintaining it very easy and very easy to set up and scale out and in when you need to. So we do have a reference architecture is coming. It should be released very soon. And it should be available on our reference architecture site here within the next month. I would say definitely within the next quarter. So with that, Ed, I'll turn it over to you to finish us up.
Okay, thanks Daryl, and thanks David. So let's talk briefly about economics. And first, let's talk about pricing. With EFS, you pay only for the storage space you use. So you're literally charged a per gigabyte per month charge, and there's no other costs tied to things like requests or throughput. The charge in our US regions is 30 cents per gigabyte per month, and in EU, it's 33 cents per gigabyte per month. So how do you put those numbers into perspective? And how do you think about the TCO tied to those prices? Well, one way to think about that, one lens through which to look at it, is to understand what it would take to build your own and maintain your own shared file system on top of AWS. And on this slide, we show what a typical configuration would look like for that. And for most file systems, most applications, customers want multi-AZ availability and multi-AZ durability. So to do that, you would have a setup like the one on this page. So you would have EC2 instances that are running some third-party software layer that manages shared access to the file system. And so you will have EC2 instances that you're provisioning to run that software. Typically, those software layers are backed by EBS, so you'll have EBS volumes in each of your AZs as well, and that's where the data is actually stored. So to have this be multi-AZ, you'll have EC2 instances in each AZ that are running the third-party software, and then you'll have duplicate sets of EBS volumes in each AZ that are redundantly storing your data across AZs. And then you will have inter-AZ traffic between those EC2 instances for the replication. And so what does something like that cost you? Well, let's say that you want to store around 500 gigabytes and you want this multi-AZ setup. So using a shared file layer on top of EBS, you'd probably provision, let's say, 600 gigabyte volumes, EBS volumes, and that gets you to an 85% utilization number, so a pretty high utilization number. And you would provision two sets of those volumes, one in each AZ, because you want to do full replication across AZs. So in terms of storage costs, you're looking at 2 times 600 gigabyte EBS GP2 volumes, and that gets you to $120 per month just for the storage. Then for the compute nodes to run this shared file layer, you'll need 2 of those, so 2 EC2 instances, and in this calculation we assume M4 XLarge instances, and that will cost you $350 per month. And then your inter-AZ data transfer costs, assuming around 5 megabytes per second of throughput, gets you to $130 per month. So the total is about $600 per month if you were to do this on your own. By comparison, EFS would be 500 gigabytes of storage times 30 cents a month, which is $150 per month. So 150 versus 600 in EFS is fully managed. And to wrap up, I'll leave with a peek into the next feature that's coming out on our roadmap, which is going to be encryption of data at rest. And that will be native integration with AWS Key Management Service, or KMS, that allows you to specify the key for encrypting your data. And the encryption and decryption, as you'd expect, will be handled completely behind the scenes, nothing that's visible to you. So when you're creating a file system, you specify whether you want to encrypt it or not. If you do want it encrypted, you specify the key, and that's all you would need to do to enable encryption. There's no extra cost, and that feature will be coming soon.